All right, let's dive right in. Today, we're tackling maybe the biggest cold case of all time, the origin of our entire universe. Think of this as a cosmic detective story. We're going to follow the clues, piece by piece, that lead us to the Big Bang.
I mean, this is the big one, right? For as long as we've been, well, we've looked up at the sky and wondered, how did all this get here? It's a question that gets at the very heart of everything. Existence, space, time itself. Now, when I say Big Bang, what pops into your head? For a lot of us, it's this image of a massive, fiery explosion happening out in the middle of a big, empty black void. It's a pretty powerful image.
But it's also not quite what happened. The real story, the scientific story, is so much stranger and honestly way more mind-bending than a simple explosion. So let's start following the evidence.
Okay, so our detective story doesn't actually start at the beginning of time. Nope. It kicks off in the 1920s with an astronomer, a really powerful new telescope, and a discovery that completely flipped our understanding of the universe on its head.
So, in 1929, this guy, Edwin Hubble, is looking at distant galaxies, and he notices something weird. Their light is kind of stretched out. It's redshifted, which is a dead giveaway that they're moving away from us. But here's the kicker. He found this incredible pattern. The farther away a galaxy is, the faster it's speeding away. This was it, the first piece of hard evidence that our universe wasn't just sitting there, it was actively getting bigger.
And I mean, the logic here is pretty straightforward, right? If you see everything flying apart now, just hit rewind, run that cosmic clock backwards. It means that everything, every single star, every galaxy, you, me, must have once been crammed together into this unbelievably hot, dense little point.
Now, this is so important to get right. It's the biggest misconception about the whole thing. The Big Bang wasn't an explosion in space, like a bomb going off. It was the expansion of space itself. The best way to think about it is like drawing dots on a balloon and then blowing it up. From any single dot on that balloon, it looks like all the other dots are moving away from you, and there's no center on the surface of the balloon, right? The whole surface is just stretching. That's our universe.
Okay, so a theory this huge, this game-changing, needs more than just one clue. It needs some serious proof. I mean, if the universe really did start as this super hot fireball, you'd expect it to have left behind some evidence, right? Some kind of cosmic fingerprints we could find today.
And boy, did it. The first piece of evidence, our first smoking gun, is this ancient echo. It's a faint glow of light that's everywhere. No matter where you look in the sky, in any direction, it's there. It's called the Cosmic Microwave Background, or CMB for short. See, for the first 380,000 years or so, the universe was this thick, soupy, super hot plasma. You couldn't see through it. But then it cooled down just enough for atoms to form, and suddenly, poof, light could finally travel freely for the very first time. The CMB is that very first light, but after billions of years of stretching as space expanded, it's now cooled down to faint microwaves.
And this is the really cool part. The Big Bang Theory didn't just find this glow by accident, it actually predicted it would be there. It even predicted what its temperature should be. And when we measure it today, the background temperature of space is 2.725 Kelvin, just a couple of degrees above absolute zero, a perfect match. It's one of the most stunning confirmations in all of science.
All right, let's look at the next clue. This whole thing is really starting to come together. The theory doesn't just predict the afterglow, it also predicts the exact recipe of the ingredients of the early universe. It tells us exactly what stuff should have been made in those first few chaotic minutes.
Think of the first few minutes of the universe as a cosmic kitchen, a nuclear furnace. It was so hot and dense, it was literally cooking up the first elements. And the math of the theory calculates precisely what it should have made. About 75% hydrogen, about 25% helium, and just a tiny pinch of other light stuff.
So, do we find that recipe? You bet we do. When astronomers look at the absolute oldest stars and the most ancient gas clouds out there, places that haven't been changed much over billions of years, they find those exact amounts, 75 to 25. It's another bullseye for the Big Bang model.
So with these clues stacking up, the expansion of space, that cosmic afterglow, the primordial recipe, we can actually start to piece together the whole story. We can rewind the clock and build a timeline of our universe, from that first fiery moment to the cosmos we see today.
And what a story it is. It starts in what's called the Planck epoch, a sliver of a second, so hot and dense our current laws of physics just break. Then, an incredible burst of hyperexpansion called inflation makes the universe enormous in an instant. At around 3 minutes in, we get that cosmic cooking, nucleosynthesis. Then, at 380,000 years, the universe cools, atoms form, and that first light, the CMB, is set free. From there, gravity gets to work, slowly pulling all that gas together over the next billion years to build the very first stars and galaxies.
But, like any great detective story, solving one mystery just opens up new ones. And the questions we're left with now are even bigger, even more profound.
So get ready for this, because it's a real mind-bender. Everything we've been talking about, all the hydrogen, all the helium, every star, every planet, every person, everything we can see, that makes up only 5% of the universe. Just 5%. The other 95%, we have no idea what it is.
So what is this other stuff? Well, about 27% of it seems to be something called dark matter. We can't see it, we can't touch it, but we know it's there because we can see its gravity at work. It's like this invisible scaffolding holding galaxies together. Without it, the stars would just fly off into space. We can see its effect, but we have absolutely no clue what it's made of.
And then there's the biggest mystery of all, the real heavyweight champion, making up a whopping 68% of the cosmos, dark energy. This is some kind of mysterious force, almost like an anti-gravity that's woven into the very fabric of space. And not only is it pushing things apart, it's actually making the expansion of the universe speed up. It's accelerating.
This is a really important point to make. The Big Bang Theory isn't a theory about creation itself, from nothing. It's a theory of evolution. It does an absolutely incredible job of explaining how our universe evolved from that super hot, super dense state. But it doesn't tell us what caused that state in the first place or what came before it, if anything. So, what the Big Bang Theory gave us is the epic story of our universe. But the story starts on page 2. That first page, the one that explains the ultimate origin, is still missing. It's still a blank page. And maybe that's the most exciting part of this whole cosmic investigation, the search for what it says.